Welcome to BADM323 lecture on Chapter 7 Telecommunications, the Internet, and Wireless Technology. This will be part 1. The lectures will be broken up into 30-minute increments, so this is part 1. We will be covering 2 case studies. The first is the telepresence that Cisco developed. We'll also cover case 2, which is the Unified Communications System with Lotus same time. This chapter discusses the principal technologies used in networking and the Internet. Do you know what the difference is between a network and the Internet? Why is networking so important to modern organizations? How many of you have wireless networks at home? How many have a smartphone that uses a 3G or 4G network? And what's the difference between a 4G network and Wi-Fi? And have you ever seen an RFID tag? We will cover these topics. The opening case, RFID and wireless technology speed up production at Continental Tires, illustrates some of the new capabilities and opportunities provided by contemporary networking technology. Prior to installing a new radio frequency identification, also known as RFID system, workers had to manually track components Continental AG used in manufacturing tires. That was not only time-consuming and inaccurate, but employees often lost track of tire components altogether. After the new RFID system was installed and workers were trained how to use it, the manufacturing plant in Saragosse Mines, France, increased production from 33,000 to 38,000 tires per day. Using a Wi-Fi wireless network and RFID tags, the company installed the tags on each of its carriers. As the carts move about the manufacturing floor, location information is transmitted to the wireless network. Handheld computers are used to confirm that the carriers have been loaded with components or have arrived at a specific workstation. The small trucks used for hauling the carriers around the plant have also mobile computers that allow drivers to quickly and easily locate a component's carrier. Barcode labels attached to each component and carrier allows the system to track each component as soon as it is placed in the carrier. The barcode labels are scanned and the data is stored in a manually inventory tracking system. The information system is continually updated so workers and managers have a real-time snapshot of the manufacturing floor. The opening vignette provides an example of how businesses are adapting to new technologies based on the Internet. It shows how companies must continually evolve as technology improves. This section shows you how these networks are actually constructed and discuss the various elements involved in connecting all of the computers. Knowing how it all works together can give you insight into changes that have taken place and an idea of what the future holds. You can also get ideas about how you can take advantage of the future now. So if we look at networking and communication trends, for the most part, all of us have grown up with a separate service provider and networks for our land-based telephones, cellular phones, and computers. We've been used to the idea that television cable service was separate from landline telephone service. Radio was separate, albeit free. Cellular telephone services were separated from all of them. Now all of these telecommunication services are converging on the Internet and either blurring or destroying the lines of demarcation. It will become harder to determine where one ends and the other starts as high-speed broadband network connections continue to expand and companies continue to develop products that meet consumer demands. According to cbdd.wsu.edu, the need for broadband access has made satellite and fiber optic cables the 2 high bandwidth transmission medias of choice in today's telecommunication services. Fiber optic cables provide a high transmission capacity. It provides broad bandwidth and capacity to transmit all forms of communication, whether it be voice, data, and video. A fiber optic connection is faster than wireless by many orders of magnitude. A single optical fiber can carry about 3 trillion bits per second, also known as BPS. The fastest wireless service, fixed wireless access, approaches 2 million bits per second, so fiber optics can be more than 1 million times faster. This slide discusses the recent developments in networking technologies. Can you give an example of convergence? How fast is broadband today? How many of you have broadband? Note that in 2000, typical internet access speeds were 56 kilobytes per second over a telephone line, costing about 25 cents per kilobit. Whereas today, broadband speeds are between 1 and 5 millibytes per second, costing about 1 cent per kilobit, or 10 cents per gigabit. Are you aware of how fast your internet connection is at home, school, or work? And if you do know the speed of your cell phone's internet connection, could you tell me? The point here is to try and raise awareness of the telecommunication systems among you all. And that's what this lecture is intended to do. Before we go much further, however, let's make sure you understand how computer networks are configured. The next figure will show you 7.1 shows a simple network structure. What you should keep in mind is that you can continually add components to this kind of network and expand it exponentially. You can take a simple desktop computer and by the way of a network interface card, also known as NIC, incorporate it into an existing network. To share network resources such as printers and to route communications on a LAN, you require special software called a Network Operating System, or NOS. Hubs and switches help route traffic on the network to the right computing device. When two or more networks are connected to each other, you need a router that sends data transmission to the correct network device. Very large networks may require multiple routers so transmissions flow more quickly. Because of the ever-growing complexity of networks, a new approach is available for managing their configurations, which are called software-defined networking, or SDN. Network administrators use the software installed on inexpensive commodity servers to manage traffic loads in a more flexible and efficient way. So taking the previous figure, 7.1, we're going to compare it to 7.2, which is a corporate network infrastructure, and compare the two. You'll see that a network that you might use in a large company isn't all that different from what you might use in your home. Obviously, there will be more computing devices and servers, but basically, you will have the same network infrastructure. So looking at a network in a large company, it really contains hundreds of local area networks, or can contain hundreds of local area networks, linked to firm-wide corporate networks. There's various powerful servers that manage websites, corporate intra and extranets, and also manages the back-end systems. They also include mobile wireless LANs, which include Wi-Fi networks. Also have video conferencing systems, telephone networks, and wireless cell phones. So looking at the network infrastructure here, this graphic illustrates the components of the large company's network. Note the difference between the wireless LAN, which allows wireless access within the office, and the mobile Wi-Fi network, which allows internet access to employees outside of the office. The advantage of telephone-based wireless system is that they do not require a Wi-Fi hotspot to work, and in fact can connect users to the entire globe through their telephone networks. Cable networks, major competitors of the telephone company internet providers, have recently developed a mobile option. Optimum Cable, also known as Comcast, has installed neighborhood Wi-Fi hotspots, allowing cable subscribers wireless access to the internet. So this slide and the following two slides will look at the main technologies in use today for networks. They include client-server computing, packet switching, and TCP/IP. Let's look at the three technologies necessary for network computing. First of all, client-server computing. The client-server network facilitates computing of all kinds of networks, including the internet. Instead of one huge mainframe with individual nodes, smaller computers called servers connect to many clients. This type of network is ideal for companies that are continually expanding their networks or replacing hardware components. Think about going to the grocery store and buying a week's worth of food. For some of us, that may be 20 packages of ramen noodles. For others, that could be quite a bit of food. You buy all of the things, load them all in your cart, and head for the checkout line. You pay for your food while it's being bagged. Assuming you bought lots of items, not all of them are packed in the same bag. You might have 4 or 5 bags, maybe even more. You take them home, unpack the bags, and reassemble all your goods in the cupboard. With this example, you've just experienced packet switching. Packet switching really is a method of slicing digital messages into parcels, or packets. It sends these packets along different communication paths as they become available, and then reassemble those packets at the destination. So previous circuit switch networks required assembly of complete point-to-point circuits. And packet switching is more efficient use of the network's communications capacity. So to explain packet switching a little more, it's a method of breaking large blocks of data into smaller chunks and routing them to the most economical way through whichever communication channel is available. When you access this lecture file on the web, for example, it appears as though all the data came in your client computer together. But they didn't. The data was broken into small packets on their way out of the server computer, and then they were sent to and reassembled on the client computer. It happens so quickly and so efficiently that you don't even notice. Packet switching also checks for transmission errors when data travels from one location to another. So how does the internet service provider manage to send your email to the right place? We're talking millions and millions of people sending email and using the World Wide Web every day. How do you keep from getting Mary's email intended for Billy in Atlanta? Notice that each computer user connected to a network has a separate individual address. No two addresses are exactly the same. All of these addresses are stored on various computers placed around the network. Software stored on routers use these addresses to route the data to the right location. Routers use protocols to help route data around the many networks to get them to their correct destination. So the most popular model for connecting networks is the Transmission Control Protocol, Internet Protocol, also known as TCP/IP. Even though this protocol was originally created for what we now call the Internet, it is easily transferred to networks of all sizes. It provides the easiest methodology for communicating between computers through standardized protocols that ignore hardware and software platforms of individual pieces of equipment. Companies can create web-based interfaces for different databases for data, input and output, and accessing information without actually combining the data physically in one huge computer. They do so by using TCP/IP models. With these protocols, they can reduce the disruption of the organization and decrease the overall cost of adding to their network. So this graphic illustrates the 4 layers of the DoD reference model for TCP/IP. Note that what happens when computer A sends a message to computer B is that the data on computer A is transferred within the computer from the application layer to subsequent layers in sequence. In this process, it is split into packets, and information is added at each stage, ultimately translating the packets into a form that can be transferred over the network interface. After traveling over the network interface, the packets are reassembled at the recipient computer from the network interface layer up, ultimately for use by the application layer. This slide looks at the types of networks that organizations use. Do you know the difference between a digital and an analog signal? Can you describe and distinguish between LANs, CANs, WANs, and MANs, and also talk about their different range of operation? Note that a network can be defined by the way the clients interact, client-server versus peer-to-peer, the type of physical medium to carry the signals, Ethernet, fast Ethernet, etc., and the way in which computers are connected and send signals to each other, also known as topology. The most important benefit of the TCP/IP model is that it allows two computers to communicate even if they are based on different hardware and software platforms. So the bottom line, all computer networks are basically the same. Many small networks can be connected to form larger networks, which in turn can be connected to the Internet. Protocols are the rules used in networks to ensure that transmission can pass between the various components. The world of telecommunications and networking has changed drastically over the last 10 years. If the pundits and experts are correct, and there's no reason to believe they aren't, then we haven't seen anything yet. So the types of networks. There are many different types of networks that organizations can use to connect their employees, managers, customers, suppliers, and business partners. It's important that the right one is used. So if we look at local area networks, also known as LAN, it's probably the most common network setup. You can have as few as 2 computers or as many as you can possibly wire together in the local area. Other devices such as printers and even network-enabled pianos can be part of the LAN. You can set up a LAN for local area processing within your company and then connect it to a larger outside network that could be linked to distant locations. Many small businesses choose to forego a client-server network architecture in favor of a peer-to-peer network in which all the computers on the network are equal. Data on one computer can be accessed easily by any other computer. Setting up a small network with this configuration saves the cost of having a separate server computer. So if we look at metropolitan and wide area networks, a wide area network is basically the same thing as a LAN, only for a broader geographic setting. This network is not limited to the space and distance, and WANs use a combination of technologies to connect all the distant locations. A WAN may take on a derivative name such as MAN or Metropolitan Area Network simply to describe its physical location. So now we're going to jump into transmission media and transmission speeds. Some experts call us a wired nation. If you consider all the methods we use to communicate, we should be referred to as a wireless nation. Our paging systems and cellular phones use microwave and satellite technologies to transmit our voice and data communications from one place to another. We have cell phones, personal communication services, or PCS, mobile data networks, and personal digital assistants, or PDAs, to help us compute on the go. Now when people say they're going to the office, it could just be as well as their car or their truck. All the transmission channels discussed in this next section combine to give you what seems to be a single clear channel from one physical location to another physical location. In fact, it is very likely that when you access the internet and call up a website, you are using a combination of twisted pair wire, fiber optic cable, microwave stations, and satellites to transmit data from your computer to another computer. So this next table provides a description and speed of each type of transmission medium you may use when communicating from one pair to another. This graphic illustrates the differences between the digital and analog signals and shows how digital signals can be sent to other computers over analog cables such as telephone and cable lines, which are analog. Note that digital signals are representations of 2 binary digits, 0 and 1, and are represented logically as an on-off electrical pulse, but in reality they're really different voltages. So it is likely that as a company grows, so will the networking needs and capabilities. So if we look at the differences between digital and analog, everything going into a computer system must be transformed into digital signals on the computer. That is, a computer understands only zeros and ones. However, in the networking world, much of the data are transmitted over telephone lines. These lines do not recognize zeros and ones. They only understand what are called analog signals, continuous waveform signals. To change the signals back and forth between analog and digital transmission methods, you need to have a modem. So looking at bandwidth and transmission speed, when you transmit the latest information from a website to your personal computer, the speed at which it moves across all transmission media is measured in bits per second, or BPS. The speed at which the bits are transmitted in each cycle is referred to as hertz, H-E-R-T-Z. If you transmit 1 million bits in each cycle, you would call the rate megahertz, 1 million bits per single cycle. The bandwidth on a communication channel is measured by the difference between the highest and the lowest frequencies that can be transmitted by that channel. So the bottom line, communication channels consist of wired and wireless media. Processors and software are combined with the protocols and transmission media to form a network. There are many different types of network infrastructure configurations. Which one is best for your organization depends on your situation. Many new network services are being introduced to increase the speed of network access and will probably reach your world in the next few years. The latest research numbers from Pew Internet and American Life website show that 79% of American adults, including 95% of Americans between the age of 18 and 29, use the Internet. Try picking up a newspaper or magazine, listening to the radio or television, or simply talking to people, and you'll be hard-pressed not to hear something about the Internet and how it is changing businesses and the way people buy and sell items. So what is the Internet? The Internet was developed in 1969 for the U.S. military and eventually spread to universities and civilian researchers. Because of its open structure, interest in its use began to grow beyond those exclusive groups. Internet working is the idea that computer networks are connected to other networks allowing data to flow freely. The Internet is best described by what it isn't. There is no single computer, no single control source, no single owner, no single entry point, and no single type of application. The Internet consists of computer networks spread all over the world through wired and wireless transmission media, which contain software codes that allow them to talk to each other. That's it. If you tried to find a single front door to the Internet, you'd be looking for a long, long time. Small businesses and individuals connect to the Internet through the Internet Service Providers, or ISPs, such as Earthlink or Cox Media. In many areas, the ISP is a small local company connected to a larger network. With recent mergers in the entertainment and internet industries, some cable TV companies like Time Warner may serve as the ISP for home users. One way of physically connecting to the Internet is with Digital Subscriber Line, or DSL. It uses regular telephone lines to carry both voice and data transmissions at very high speeds. Since many home computer users already have cable TV installed in their homes, the telecommunication industry is using cable internet connections to pump data into the home. If you have many people in the same cable line, each individual accessing the line will notice progressively slower speeds as the number of users increases. It is much faster than a dial-up modem, though. Larger organizations such as universities and corporations can afford what they call a T1 line, which supports extremely high rates of data transmission. These lines are capable of carrying voice and data transmissions of over 24 channels, which make them ideal for larger networks. But because they are expensive, it's not something you'd install in your home. Every address on the Internet, whether it's an email address or a website address, is nothing more than a series of numbers, called Internet Protocol Address, or IP for short. Computers spread around the Internet and various networks convert a series of numbers such as 195.128.15.11 to an easily readable address such as www.usatoday.com. The domain name system, or DNS, was devised because it's much easier for people to read letters and words than to work with a series of numbers. The DNS uses a hierarchical breakdown of addresses, such as figure 7.6. So domain names used in the email addresses and website addresses are easily obtained through several services such as www.networksolutions.com and www.register.com. So how do you get a domain name? Be the first to request a unique name and pay the required fee. That's basically all there is to it. This graphic illustrates the architecture of the Internet. Note the MAEs, or the Metropolitan Area Exchanges, are hubs where the backbone intersects regional and local networks and where backbone networks connect with one another. If we look at the Internet architecture and governance, even though no one owns the Internet as a whole, parts of it are owned and controlled by many different private and public entities. Network channels in the United States are largely private, while in other foreign countries, for example China, The government owns the backbone. To ensure continuity and connectivity throughout the world, various organizations have been established to help administer the Internet. These include the Internet Architecture Board. They define the overall structure of the Internet. The Internet Corporation for Assigned Names and Numbers, or otherwise known as ICANN, ICAAN. They assign IP addresses. And then there's the Worldwide Web Consortium, where they set standards for the web. Just remember, no one owns it, and it's not free.
Innovation is the key to the world's future. And one of the exciting things about India is the young people in the education systems allow people to think out of the box about new ideas. At Cisco, we pride ourselves in bringing out new products and new capabilities. And we have an innovation center that is able to bring new products to market very quickly. We asked this group called Emerging Technologies to think like Star Trek and suddenly allow us to communicate wherever we are in the world to deliver services to our customers virtually. And we had a person by the name of Martin DeBeer head this up, and Martin was going to be here today, except that he had to be doing a small acquisition back at home office, and he was also teaching a leadership class. Martin, I just wish you could be here. Martin, is that you?
Hi, John.
How
yes,
are you
that's
doing?
me.
It's good to see you.
Namaste.
Yes, Sam. You know, it's amazing. I thought you were teaching classes in San Jose. Where are you?
John, I'm actually in California, 14,000 miles away, and it is very early in the morning here, but I'm delighted to be joining you today for this fantastic event in India.
So we showed Professor Kalam earlier the capability to do healthcare remotely by using video. But you're really talking about the ability to virtually not only have meetings together, but I can see you like you're right in front of me.
Correct, John. As you know, telepresence is about bringing people together around a virtual table. And what we're showcasing here today for the first time is an on-stage experience where any resource can be anywhere in the world on demand.
So your ability not only to give speeches like this in the future, but all of a sudden to have doctors come as though they were physically there with the patient, or the ability to bring groups together to not only communicate and counsel quicker, but to change things. Now, Martin, how does this work? Tell me how you did this and how your team did it.
Well, John, as you know, our technology is very, very powerful in the way that it can put you virtually in a different location using very high-definition video and full spatial audio technologies. And of course, this is very important in business. As we globalize, we need to transform our business models in order to scale our resources anywhere in the world, put our best talent in front of our customers at a moment's notice. And that is what telepresence is all about. It will allow us to transform our business. It'll allow us to innovate in new ways and to draw upon the collective wisdom of talent that may be anywhere in the world, including in India.
So, Martin, I know that we've already done 28,000 meetings at Cisco by using telepresence. And you gave me a forecast of making it $1 billion in 3 years in terms of orders. Are we on track for that?
John, I can say we are on track for that, and the customer interest we are seeing is absolutely phenomenal, and it's growing every day. And I think as we continue to extend the experiences of telepresence, it will only get more exciting. And of course, telepresence is also a green technology, so as we globalize, we also have the ability to do it in a very responsible manner.
Well, it is truly exciting, Martin, what you've done. I asked you to build a product and beam me up Scotty, where I could be Scotty in Star Trek, and this is even better than that. It begins to open up the imagination of what is possible. I don't want to keep you from your other 3 meetings you're doing this afternoon, but Martin, for all of us, thank you for being here, and thank you for being part of our innovation engine.
Thank you, John.
Have a great day.
Now that you've viewed this video, this week's individual participation will be included to answer one of the following questions. Go to the individual discussion forum for week 4 and answer one of these questions. That's it for part 1 of the Chapter 7 slides. Please be sure to view part 2 of Chapter 7 to get a full understanding of the entire chapter. Thank you for attending.